Good morning all of you. We discuss about properties of refractory materials. First property, refractoriness. Refractoriness is the ability of a material to withstand high temperatures without melting. So, a good refractory should possess high refractoriness property. Here, refractoriness is a measure of softening temperature because most of the refractory materials are made by several amorphous metallic oxides. So, they possess only softening temperature rather than sharp melting point. Higher the softening temperature, higher will be refractoriness property. Here, softening temperature measured by pyrometric cone test. In this test refractory material and number of standard refractory materials are cut into pyramidal shape like this. It is the test refractory material whose softening temperature is to be determined. It is the first standard refractory material. Its softening temperature, for example, 1000 degrees centigrade. It is the second standard refractory material. Its softening temperature, for example, 1100 degrees centigrade. Now, these materials are subjected to heating. At their softening temperatures, the materials gets softened and cones bending downwards like this. Suppose if the cone of the test material and cone of the first standard touching the base at the same time, then softening temperature of standard material would be the softening temperature of the test material. Suppose if the cone of the test material and cone of the second standard touching the base at the same time, then softening temperature of this standard material would be softening temperature of the test material. Suppose the cone of the test material touching the base earlier than one standard but later than other standard, then the average of softening temperatures taken as softening temperature of the test material. So in this way, softening temperature of refractory material is determined. Second property, strength or RUL, refractoriness under load. Here, refractory material not only possess high refractoriness property but also possess mechanical strength at high pressure, at high temperature, even under load. Here, the strength of refractory material determined by applying constant load on refractory material. For example, alumina and fire clay refractories collapsed or softened below their softening temperature when load is applied. So, these materials are not said to possess mechanical strength, but silica refractory softened or collapsed only at their softening temperature even when load is applied. So, this material said to possess mechanical strength. Now, next property, dimensional stability. A good refractory should possess high dimensional stability at operating temperatures. Practically, materials expand when heated and contracted when cooled. The expansion and contraction changes the dimensions of a refractory material. Here, the expansion of refractory material decreases the internal space of the furnace in which refractory materials are used. Moreover, the repeated expansion and contraction leads the internal stress in the material. It leads to breaking or cracking of the refractory material. So, a good refractory should possess high dimensional stability at operating temperatures. Next, chemical inertness property. Good refractory should be chemically inert at operating temperatures because In most of the furnaces, the environment is either acidic or basic. So the material should not react with environment. Otherwise, lifetime of the material decreases. Next, porosity property. Due to manufacturing defects, refractory materials possess pores. Here, the porous material easily entrapped by the air or atmospheric gases. So these gases react with the material and decreases its lifetime. So a good refractory should possess low porosity. Next property, thermal conductivity. In some industries, refractory materials of low thermal conductivity and high thermal conductivity are used. This thermal conductivity phenomenon explained by porosity property. Here, highly porous material easily entrapped by the air or atmospheric gases. That air entrapped material acts as poor conductor of heat. So, for low thermal conductivity, high porous material is used. For high thermal conductivity, low porous material is used. Next property, thermal spalling. Thermal means heat, spalling means breaking. Here, the breaking of refractory material at high temperatures, or the breaking of refractory material due to rapid changes in temperature. Here, due to rapid changes in temperature, the material expands and contracts. It leads to internal stress and strain in the material. It leads to breaking of the refractory material. So a good refractory should have high resistance to thermal spalling at operating temperatures. Next property, electrical conductivity. Here, good refractory should have low electrical conductivity, because in many electrical furnaces or electrical ovens, refractory materials are used. Here, refractory material should have low electrical conductivity, otherwise that gives electrical shock. So a good refractory material should have low electrical conductivity. Most of the refractory materials are poor conductors of electricity except graphite. It is about properties of refractory materials. Thank you.